Yeah. Let me right now interact with you all first because we have stopped in between uh, and we want to resume from there onwards. Okay. I guess I'm audible to all of you, right?
Yes, sir.
Yes, sir.
Uh, I would like to know from your end where exactly right we have stopped. Anyone of you?
SNMP version 2 we have done, sir, and version 3 it is started.
Yeah, version 3 we have started.
Yes.
So in the version 3, I think we have started with SNMP V3 architecture, correct? Uh, and then SNMP V3 applications. Then we have also started with security model of SNMP V3, I guess. Am I right? And also SNMP V3 message format. Yes or no? Yes?
I think SNMP V3 applications on what's it to start, sir.
Uh-huh. Yeah, class number 22 is right now over, I guess. Correct. And that slide I have shared with you all. Yes or no? Class number 22.
Yes, sir. 22 is over.
22 is over. We need to start from 23. Hmm? I'll start sharing my slide. That's in 23rd class. Yeah, my slide is visible to all of you.
Yes,
Is
sir.
it? Yeah.
Yes, sir.
Okay. So we have very, less time actually now. Probably from today, if I start your class, hardly I'll get, 8 to 9 class. So within that, we need to complete the entire, syllabus of you. Followed by there will be a third test, then quiz also, and all of you need to present your right seminar assigned course contents. I guess that I have given it for you from um the third chapter, I believe. Okay, have you gone through it? Any one of you? Any topic which is assigned? Could you say roll number one? Or roll number two, roll number three? I think if you open up your assignment, seminar assignment contents, you may get the details. That one I have already shared with you all. So from next class onwards, you are supposed to be plan it accordingly. Okay, that's what I told you earlier also. Don't postpone your work. So start preparing it as per the assigned work. We never get any additional time. Okay, we need to rush towards to complete your syllabus as well. Anyway, today's class I'm going to talk about with SNMP V3 user-based security model. Okay, you understood many aspects of SNMP V3, right? Architecture, wherein you have two major components. One is an SNMP engine, the another is an SNMP applications. We have completed those two parts as well. Now we are moving towards SNMP user-based security model, wherein security model also we have understood that various aspects of security threats which we come across in SNMP version 3, which includes the first one may be right modification, masquerade. Then we have understood right a message stream modification and disclosure. Apart from that, we have also understood that the security services of SNMP v3 with security subsystems components, along with that, we have there is an authentication model, privacy model, and timeliness model, and the functionality of each one as well. Okay, with this, right background details, let me talk about SNMP v3 user base security model in detail. When we talk about user security model, always the messages are going to be exchanged between the manager and the agent with data integrity checking and data origin authentication. Because the moment we talk about message exchanges that need to happen, if there is any a modification in the data, or if there is any data which is accessible by the unauthorized user, okay, then it leads to various breaches in the data exchange between your client and the agent and the manager, that we need to right address it using there will be an SNMP v3 user based security model. Yeah, to talk further, your SNMP v3 define conceptual interfaces between generic USM services, okay, that is a user security model services, and self-contained authentication and privacy services. There are two primitives associated with authenticated services. One is an outgoing authenticated message. The another one is incoming authenticated message, right? Wherein in both the cases we use there will be in privacy services that we can provide it using encrypt your data and decrypt your data. Of course, you've already come across what is an encryption, decryption, the different kinds of there'll be an encryption and decryption techniques we use to uh, right protect our data. Uh, Maybe you might have studied in case of our information security, or maybe right security engineering, or maybe even in case of there'll be a cryptography, right, networks and security as well. Anyway, my focus is on there'll be an outgoing authenticated, incoming authenticated message, along with some of the algorithms or protocols we use in case of right encryption and decryption of your data. Yeah, this is the user based security model for outgoing messages. So if you look at this, we have right on the right part security subsystem, which includes user based security model in a short term you can call that is an USM. On the extreme right, you have two models, that's a privacy model and authentication model. On the left hand side, you have there been message processing model. Okay, you can call that as an MPM, right? MPM is trying to invokes the subsecurity subsystem initially by providing uh, a lot of information, which includes MPM information, that is a message processing information, header data, security data, and scope protocol data unit. In turn, when it comes to user-based security model, the user security model is trying to provide the details to the privacy model with encryption key and scoped PDU. In turn, the privacy model is right, providing the data privacy parameters along with there'll be an encryption right a key code. Once it comes to the LBN security subsystem, right, that is going to be authenticated again with the help of authentication model. Again, the authentication model is going to forward that whole message back to the user-based security model. Once it comes to the user-based security model, that information right forwarded back to the message processing model with by verifying their main security parameters once again. So this is how right the outgoing message verification is going to happen it with the help of privacy and authentication model. I think from the examination point of view as well, this is very important. Similarly, we need to understand there will be an incoming message also. What are the different models we may have it? Maybe where we talk about there will be an incoming message, that is just there will be the reverse process of right your outgoing messages. Yeah, I think I have explained you all these details for you. Okay, I'll just skip this slide. I'll move on to the next slide. Yeah, this is the user-based security model for incoming messages. If you observe that the outgoing message and the incoming messages, it looks the same kind of information in both the cases, but whereas right in the first one we are doing, there will be an encryption key that is going to be right used by there will be the privacy model, but whereas in case of privacy model, here we use there will be a decryption key. Rest of the process is same, but first authentication model is going to be checked whether it is right key or not. Once it is a right key, obviously the data is going to be exchanged with your message processing model. So that is the reason the steps which includes in case of there will be an incoming messages or processing secure incoming message, reverse of there will be an secure outgoing message. That's the first stage. And authentication validation done first by the authentication model. Okay. And decryption of the message done then by the privacy model. I think you can easily understand that here also. Again, MPM is going to invoke the security subsystem. Again, USM is going to forward right the authenticated key along with certain parameters to the authentication model that's going to be verified, and that is going to be decrypted with the privacy model, and the whole message is going to be forwarded back to the LBN MPM. So that is how things are going to happen it in case of incoming message. So probably you can expect there will be a 10 marks question wherein you have there will be an incoming message and there will be an outgoing message. If it is an only one, maybe 6 to 7 marks of the right question you can expect here. Right? Just a minute. Yeah. Do you have any questions? You can ask me here. Hello. I'm audible to all of you. Banu Prasad, do you have any questions? Banu Prasad.
Yes, sir, you were audible, but no question, sir.
Yeah. Is it clear?
Yes, sir, clear.
Let me move on to the SNMP V3 MIB objects. I think even right from the beginning, the main focus of your SNMP is MIB related objects. Okay. We start with SNMP models, that is at 1.3.6.1.6.3. The moment if I'm talking about that, you need to understand that that is related to internet based right MIB object. Okay, you need not write that. You can start straight away from this particular MIB object, wherein we have two groups in case of SNMP V3 MIB object. Okay, on the left hand side it talks about SNMP framework MIB with an OID of there will be 10, and further that is categorized into one as SNMP framework MIB objects and SNMP framework admin right MIB objects. So in turn, the classification happens further into SNMP engine and SNMP authentication protocol, SNMP private protocols. If I look at on the left hand side, probably all of them are related to authentication and validation of your SNMP architecture. That's one part of it. On the right hand side, we have SNMP USM MIB. So, when I'm talking about USM MIB, that is related to user security model, what we have already understood relating to the security model of SNMP v3. Then SNMP USM MIB objects, wherein we have USM user, where we have two types of users in it. One is in spin lock users, where most of the time repetitive tasks are going to occur. I mean, you come across with so many groups further in that particular group, and the second one is USM user table group. So in the sense, all of them belongs to right user security model object identifiers. Yeah, we have certain parameters in right SNMP v3 architecture relating to the SNMP v3 MIB objects. So these parameters, which includes message authoritative engine ID, which comes under SNMP engine ID, and message authoritative engine right boots. Okay, SNMP engine boots. Then SNMP, that's a message authoritative engine time relating to SNMP engine time. Message username, USM username, and message authentication parameters. So comes under there will be an USM user authentication protocol. And lastly, we have message privacy parameters comes under there will be an USM user privacy protocol. So what I mean is, the moment you look at your SNMP v3 MIB objects, we have there been well specified, security parameters. Those parameters you need to be identified. Even here, the question also may be, identify the various security parameters used in SNMP v3 right architecture, and write down the corresponding MIB structure. So then you need to specify these parameters, and you have to write your SNMP v3 MIB object tree structures as well. Let me move on to the next slide. Okay, the next part is on authentication protocols. I think all of you are very familiar with the need of authentication protocols. Of course, you might have studied by this time different types of there'll be an authentication protocols. Okay, maybe as and when you start working with different functionality, you may use your own authentication protocol. There is no hard rule that you're supposed to use this particular protocol itself. Even when I'm talking about your SNMP v3 security model, also you can use your own authentication protocols. Having said that, there'll be in different types of there'll be an authentication protocols. Okay, so basically we have there'll be an HMAC. I think you can notice at the last line of this particular slide, there is an MD596. That's one thing, and another one is an HMAC, right? SHK96. Okay, so where in the first letter here stands for the cryptographic hash function, that is an H. Okay, and we are trying to use that hash function for generating the message access code that stands as there'll be an MAC, that is an message access code. That's how the formulation of this protocol emerged basically. There's an HMAC 95 and 96. So most of the time, we use there'll be an MD5 hashing algorithm, to authenticate the messages. That's where we talk about HMAC MD5. So that's MD5 is a message digest. And the another one, what we have here is SHK1 hashing algorithm also. It is left to you again. I mean, it depends upon the organization, what they are really using it. There is no rule that you're supposed to be use this itself. So what I'm trying to convey is that you can really think about these authentication protocols for authentication your data. Okay, so where you can derive from a password chosen by the user. The digest 0 is repeat password of 2 to the power of 20 octets. You just imagine a scenario. If you have such a maximum number of octets to get that, the kind of the password code you have is really huge. Okay, any kind of cracking is a very complex process in this particular case. That's where we call that is an digest one, that is an H digit 0, and the another one is an digest 2, where you're trying to find out engine ID. Engine ID is SNMP engine ID. I think you have come across of how the SNMP engine ID is going to be generated, right? That is going to be odd with there'll be a digest 1 hash function algorithm. Okay, that is going to be treated as there'll be an authentication key here. Let me move on to the next kind of protocols which we really think about in case of SNMP v3 architecture. This could be categorized into two types. One is a network structure, the another one is an operation, right? Where in the network structure we have two types. One is a centralized scheme, the another one is a distributed scheme. When we talk about a centralized scheme, I think the whole focus of our networking, right, majorly based on these two factors, centralized scheme and distributed scheme, where I stress more on centralized and there will be a distributed scheme as and when we discuss something as well. Okay, centralized scheme is controlled by your centralized servers which are deployed at one place, right? We're controlling, monitoring right, becomes very easy. But the problem with the centralized scheme is if any issues occur, the whole system comes to an standstill state. Okay, that is the major issue. But whereas in case of a distributed system, it is not so, right? Where your servers are deployed geographically at different places, wherein, okay, you are not going to be monitored at one place, which is going to happen it at different places. As a result of that, even if one server fails, right, your operations remains going on with any issues without right any issues basically. And of course we can look for, there'll be in various schemes. Some of the examples have been summarized here, right? It is not necessary that you have only these schemes, because as and when you start working with the different organizations, they have their own method of schemes to implement that. Probably as and when you start working with the industries also, I am sure you will come across certain, there'll be a centralized scheme and distributed scheme of your own, okay, that you can summarize it as well. Coming to the right hand part, wherein you have, there'll be an operation kind of key management, so which happens based on two mechanisms. One we call, there'll be a probabilistic scheme, the another is a deterministic scheme, right? Where in the probabilistic scheme, always we go ahead with different what do you say, there'll be an ratios with the problem definition. The best part is there'll be a random keying schemes. You can easily use it in case there'll be a probabilistic scheme. Whereas in a deterministic scheme, where right, any kind of implementation which happens with a finite set of goals and time as well. So that's where we call about, there'll be a deterministic scheme, and you can use, there'll be in various schemes here also. If I look at the deterministic scheme and a distributed scheme, right now most of them are mapping to one another, even though we talk about these schemes could be used, but those schemes are going to be implemented with the help of deterministic and distributed schemes, right, relating to an authentication of your own data. Moving further, we have, there'll be another set of protocols that we call, there'll be discovery protocols. Okay, so I'm just taking one discovery protocol where the Cisco mainly uses that we call, there'll be CDP, that is a Cisco discovery protocol, right? It's an information gathering tool used by network administrators to get information about directly connected Cisco devices. I think even from the network model which is there on the right hand side, you can understood that, right, where exactly the SDP comes into active. It enables you to access a summary of protocols and address information about a Cisco device that are directly connected. So when I'm talking about, this is a proprietary protocol, hence, this is a Cisco discovery protocol. Okay. These advertisements contain information such as the types of devices that are connected, the router interface they are connected to, the interfaces used to make the connections, and the model number of the devices as well. So wherein we have, there'll be two types of neighbors. One we talked about layer 3 neighbors, and another one is in layer 2 neighbors. Okay, so as you know that in case of your internet model, the moment we talk about a layer 3, obviously that is in your network layer. Most of the time we use, there'll be an router as network component. However, you can also use, there'll be an your switches as well at the network layer. That is possible. Okay, so if at all you want to know the kind of devices which you use right at various levels, you can just utilize the kind of protocols which are available for you. Yeah, this is another scenario which talks about there will be in CDP. Okay, once you simulate your network components using the Debian packet tracer simulation tool, and you would like to know the kind of devices which you use it, you can type a command that's in show CDP. Okay, that is in Cisco Discovery Protocol in a short form. Okay, where you get these details. I mean, that is in global CDP information, not the Debian local. Okay, so which talks about sending CDP packets every 60 seconds, whole time, sending a whole time value for 180 seconds, sending CDP version 2 advertisement is going to be enabled. As a result of that, you want to track something and you want to right now troubleshoot something, right, based on this information or the kind of devices which are connected in your network. You can easily notice and you can take a call what you're supposed to do it. Okay, that's possible. And also the next command, let us see, right, that is show CDP, that will be a neighbor. So that is in a short form again, wherein you get to know that will be in the kind of components we use it, along with there will be in specific protocols we come across net. So as a result of that, right, you get there will be the complete summary of it. Okay, see, look at that internet. Okay, fast Ethernet, that is the port number what you have it, and whether it is right router, or whether it is connected to router, or the kind of router which you use it. Okay, you get there will be the complete device details of the will be in layer 2 and there will be in layer 3 as well. Yeah, let me move on to the decryption. There'll be in protocols. Okay, so these are all you can do it using for the encryption purpose. When we come across to the decryption, as you know that, right, your cryptography algorithms categorized into two types, where you come across symmetric and asymmetric. When we talk about a symmetric, where your the code remains same. Okay, whereas in asymmetric, that's going to be differ with one another. Okay, when we go ahead with symmetric, where we categorize that into two types basically. One is black cipher, the other one is in stream cipher. Okay, where in a block cipher we have there will be a number of right decryption protocols, that is DES, 3DES, Bluefish, Two-Face, RC2, RC5, RC6, AES algorithm. I think you have come across DES and there will be an ES algorithm in case of there will be a symmetric part of it, right? And when it comes to the stream cipher, we have an RC4, A5/1, A5/2, Pike, Wake, and Sober. I mean, on the right hand side, whatever it is there, the year in which these protocols were introduced for authentication, decryption purposes, basically. Coming to the asymmetric, we can go ahead with RSA, DSA, Diffie-Hellman algorithm, then even Gamel, okay, algorithm, elliptic curve, there will be an algorithm. So even though these algorithms were introduced at the very early stage, till today, right now, for our applications, we are using one or the other applications. Sometimes we may go ahead with symmetric, sometimes we may go ahead with LBF asymmetric, cryptographic algorithms. What I mean, why I'm talking about all these things here is, when I'm talking about SNMP v3 security model, to build your security model, to validate your privacy model and authentication model, certainly you can go for the Debian, these kinds of Debian, algorithms. Okay, so at least you must remember, one or two algorithms names, not in detail, or how the this particular algorithm is going to be functioning it here. Okay, since you have already studied in case of network security model, so some of the algorithms names you must remember, which we use in case of SNMP v3. I think this is what is relating to your SNMP V3 security model aspect is concerned. If you have any questions, you can ask me. Otherwise, let me move on to the next stage. That is the last part of your SNMP V3 and the third unit as well. Do you have any questions, Shankarama or Sukrita? You can ask me. Do you have any
No,
questions?
sir.
Sukrita?
No, sir.
No. Yeah, let me move on to to the last part of it. There is an access control. The moment we talk about an access control, first and foremost, it will come to anybody's mind that, oh, whether I am able to access this device, whether I am able to access this file. Okay. If I am able to access this file, can I modify it? Can I notify this file to someone else to do something else? Okay. Or whether it is not accessible. Or if it is a file permissions, we talk about read, write, execution. So these are all normal access policies. We do it. So as and when we go ahead with your SNMP V3 architecture, we must remember some of the elements of VASM. That is in a short form. I mean, that is a VASM. That is a view-based access control model. Of course, we talk about groups, name of the groups comprising security model and security name. That's one part of it. Of course, that is not there in case of version 1. And in case of security level, no authentication, no privacy, authentication, and no privacy, authentication, privacy. That is in SNMP version 1. But don't bother about SNMP version 1 now. Okay, look at SNMP version 3 with along with the Debian security model. Yeah, this is the access control model. What we have it in case of SNMP V3, where this model consists of a number of elements. We can identify there'll be 5 elements. Okay, the first element is there'll be the groups. The groups talks about most of the time, a group name. This we do it as and when we start doing any kind of operations where the size is more and more. Unless you are not forming a group and going ahead with number of users with larger members, then tracking, controlling, monitoring becomes a very difficult task. So that's where we talk about there'll be a grouping is needed. That's one part. And the second part is there will be the security level, okay, wherein we talk about what kind of security level we provide into your objects, whether it is no authentication, no privacy, or authentication with no privacy, or authentication with there will be privacy. I mean, it all depends on how you're trying to set your privileges to access your device, maybe instantaneously or maybe in a realistic situation as well. And the next one is context. So where we talk about SNMP context is a collection of management information accessible by an SNMP entity. Each SNMP engine has a context table that consists of a list of locally available context by a context name. Rather, I could say that to what is the context of your operation basically. That's what is wherein you have there'll be the number of tables and operations in it. That's the thing. And we have MIB views and there'll be view families, because the moment we start having a group security level and a context, certainly some kind of MIB tree structure is going to be formed by using these models. And lastly, once you have, there will be the entire family of MIB view and families. You need to come across, there will be an access policies. Access policies. Again, I've already mentioned that whether it's a read view, write view, or notifiable view, that we need to look into it. Yeah, that is what is observed from the VASM processes. VASM is I've already told you that is an So we have, there will be an most of the times we use, there will be an VSM with respect to different applications. Okay. Let us look at that. What is the first process? I think the first process is who are you? Okay, that is the group. That is the first process model, where these kind of questions are going to be addressed. Maybe security model, security name principle, security to group table, no group name. Uh, we are trying to find out who all belongs to that particular group. Okay, so some of the elements have been mentioned here. That's the first thing. And the second one is we have, there will be an go where context. That is the second group, in the sense that where do you want to go? So where do you want to go with respect to context to be accessed? Okay, that you need to be remember. That's where we talk about a context name and a context table. Okay, and no such context or context name that you're supposed to be specified. And the third group is how secure are you to access the information. Okay, the question mark is how secured are you, secure level. Okay, that is what is the third process, what we have it in the case of your VSM process. Okay, which includes security models, security levels that are going to be specified. And the fourth one is an access is allowed or not. Okay, so in the sense, why do you want to access the information? Okay, whether it is read mode, write mode, or notification mode. Notification is nothing but a sending mode. Okay, that you need to be look at the fourth step. Once we moved on to the access mode, based on there will be the rights, whatever we have it, then we are moving towards there will be an what object you want to access it. Okay, that's where why do you want to access view type, that is relating to there'll be an object type. That is the fourth one, which comes under so many accessible privileges which you are going to be set for it. And lastly we have which object do you want to access it. Okay, that's where we talked about, there'll be the last one, which object do you want to be access it. Okay, instantaneously, that is what is the right last stage. You have it in case of view based access control model. Okay, I think this diagram you're supposed to be write it clearly to talk about SNMP v3 VASM process. Okay, and the subcomponents which are included in it, you need to be elaborated more in detail. Yeah, this is what is I've already mentioned. Altogether, this entire diagram talks about these steps. That's it. That's in 6 questions, which are just now mentioned. Who are you? Where do you want to go? How secured are you to access the information? Why do you want to access the information? What object do you want to access? Which object do you want to access it instantaneously? That's what is first, second, third, fourth, fifth, and there'll be the last one from this particular diagram. Okay, those steps are summarized. Yeah. Yeah, do you have any questions? You can ask me here. Do you have any questions? Karthik? Karthik? Sagar? Suprita? Mahesh?
No, sir, I don't have any questions.
Pramaya? Aregde? Deepak? I think, yeah. Let me move on to the next stage, right? This is, view-based access control model of your MIB views, similar to the SNMP v3 MIB views. SNMP VSM MIB, it's an object identifier as 16, where your essay, VSM MIB objects further categorized into VSM context table, VSM security to group table, VSM access table, and VSM MIB views. So whatever I have mentioned here, USM MIB objects, that is categorized here with 5 groups again: context table, security to group table, VSM access table, then MIB views. Where MIB views further is spin lock, and there'll be a tree family access table. So because the moment we get, there'll be the tree structure, we can able to write down, there'll be the object identifier for your SNMP v3 architecture for the given details. Yeah, this is where we talk about VSM MIB views. 1 minute. And the class actually. Please wait. Please wait. We have 4 tables to use to achieve the access control. The first group is group defined by security to group table, right? And the next table is context defined by context table, because the moment we talk about a context table, the scenarios which we define are different. Based on that, your context table contents are going to be verified. As access determines access allowed and the view name as well, okay, which relates to send, write, read, commands basically. Then lastly, we have the view tree family table, determines the MIB view, which is very flexible. So what I mean is your VSM table, right, access control is based on these 4 factors. Yeah, this is one simple view which we talks about it. Okay, of course, you don't have the tree here. Maybe you have in the next right slide. So where we talk about system, that is on 1.3.6.1, 0.2.1.1. I think you can easily understand that there'll be 4 right OIDs which we use it subsequently. You can understand that what may be the requirement for 2.1.1. Accordingly, you can just scale up or write your VSM MIB views. Okay, sometimes your VSM MIB views looks very simple. Okay, see, the first one is very simple. You can easily understand that what is it is, but in a complex view, obviously, it may not be possible to write it any OID just like that. We need to have the right complete VSM MIB view. So then it is possible to write the OID for that. So that's where we talk about here. Complex view is an all information relevant to a particular interface system and interfaces groups, which includes right family view subtrees, view with all columnar objects in a row appear as a separate subtree, and also you can have there will be an right object identifier with family name paired with bit string value. Sometimes it may be given, and that we are supposed to be take it to write your OID structure. Yeah, this is where the tree structure looks like that. Along with there'll be the OIDs, right? That is VSM MIB views with 5. Okay, then view spin lock 1, then tree family table 2. Of course, we have there'll be a different family tree family of VSM view, where each one identified with there'll be in corresponding OIDs relating to there'll be an family view name. Okay, maybe including family name subtree, then a tree family masking, right? And on the other side we have there'll be an view tree family type, then storage type, and lastly we have there'll be a family status. See, if I look at all these things, so all these table summary which are totally related to VSM tree family of your SNMP v3. So that is how we should view it, or we have to understand in that manner, so that writing becomes much more easier as and when we proceed with your VASM MIB views. So it's not much complex. Once you have, there'll be the tree. It's something like that. You start from, there'll be a root, and proceed towards, there'll be the leaf node of a tree. uh, Again, how you are accessing it, that path you need to consider it, and right, there'll be the corresponding object OID of it. That's it. So that ends the matter in case of anything. It is not only in case of right, your VSM. It may be talking about, there'll be the processing order of your tree from, there'll be the root node to the leaf node. That's it. Okay. So write the corresponding object ID for that. So this is another example what we have it. System again, this is a simple right, VSM MIB view structure. I think you can easily write many more as well. I think there'll be two more questions for you. I'll share with you all, right, and you can definitely start looking into these questions answers, right. And in fact, these two questions, right, were selected from the Libyan textbook exercise questions itself. Okay, so it's very simple. It's not very complex, but the kind of assignment or the kind of assumptions which you do it for accessing it your row, accordingly your accessing view and table structure is going to be varied. That depends upon the IP group which you select, the IP address table row value, whatever you select it, right, once you start writing your answers. Okay, yeah, that's it for today's class for you all. Okay, with this, right, the unit 3 is completed without leaving any content. Now we need to start up. There'll be in unit 4. I think we need to okay, start. Hello. Hello.
Yes, sir. You're
I'm audible.
audible.
Yeah, audible.
Yes.
No? Yeah. That's what. 1 minute. Where is that? Yeah. I mean, with this, unit 3 contents got over now, right? We need to move on to, there'll be an, unit 4 from today, I mean, from tomorrow onwards. I think tomorrow I'm unable to take the first hour class. I got there'll be an examination duty. Instead, right, morning, shall I engage tomorrow at 7 to 8, 1 hour? Is it possible to all of you to attend? Evening? Hello?
Okay, sir. Yes, sir.
Yeah, I think all of you, I've assigned some work to all of you. You can start working towards it. I will also verify it whom supposed to be present it, or else I'm preparing myself tomorrow's class as well. Get tuned with the second semester course contents as well now, because you are again migrating from sem 1 to the sem 2 and resuming it. Okay, whatever we have discussed so far, try to write recap once, so that definitely you can understand and go in a better manner. Okay, so with this I'll stop my class for today's session. Do you have any questions? You can ask me. Any other doubts? I mean, shall I have, there'll be a second quiz this Saturday afternoon, 2 to 3, something like that. I mean, 2 to 2:20. Quiz 2. Is it okay? Hello? Vijay Kumar?
Yes, sir.
Shall we have a second quiz on coming Saturday?
Yes, sir.
Huh?
Yes, sir.
Yes. No voice only. What about others?
So shall we have it on a weekday, sir?